Okay, so here's the question for this week's Quideo. In the first part of Part A, asks you to create a 99% confidence interval. And so to do that, we have to do PANTS. And the first part of PANTS is the parameter of interest. And for this problem, the parameter of interest is the proportion of vaccine-eligible people in the United States who have received the flu vaccine. And so after that, we go to A, which is the assumptions. And so our first assumption is that the sample is random, which we got that from the problem when it says a random sample of 2,350 people. And so the second part are the assumptions. And so for a proportion, we're going to use the rules of thumb. And if it was a sample mean, we would use the central limit theorem. And so there's two rules of thumb. And the first one is the small enough rule. And so in order to do that, you do n, which is the sample size, times 10. So we did 2,350 times 10, which equals 23,500 people. And so we're going to assume that there are more than 23,500 vaccine-eligible people in the United States. So that's saying that our sample is small enough. So we can check that one off. And then the second rule of thumb is the big enough rule. So in order to do that, we have to do n times p hat and n times q, and both of them have to be greater than or equal to 10. And so first we did this, and we did 2350, which is n, and then we did the proportion of people who have received the vaccine, which is p hat, which gave us 978, which is greater than or equal to 10. And then we did the n times proportion of people who haven't received the vaccine, which gave us 1,372, which is also greater than 10. So all of those assumptions check out, and we can move on to n, which is where we name our confidence interval. And so these are all the different confidence intervals that we could choose from. And because we have a proportion, we were going to use the 1 proportion z interval. And so we're going to write that out for our test. And then for t, we're going to use the formula, which is this, and then we have the statistic. Because it's a proportion, we're using p hat plus or minus the critical value, which is going to be the z-score. And then we have the standard deviation of the statistics, which is that under the square root. So then we plug in our numbers that the equation gives us. So we have the p hat, which is from the problem, and then the 2.58, which is what we got from a 99% confidence interval, which we found from our z-scores sheet, and then the 0.05%. And then we plug in P, which is what we got from the entire population, which is the 45% of vaccine-eligible people have received it. So we're going to use that because P is from the whole population, while P hat is just from the sample. And so once we plug all that in, our confidence interval is this value. So then we have C, which is our statement in context. So we are 99% confident that the true proportion of the parameter of interest is between the confidence interval that we've gotten. So then we have to go to the second part of the problem, which wants you to comment on the belief that 45% of vaccine-eligible people have received the vaccine. And so because the highest value in our confidence interval is only 0.44264, which is about 44%, we know that 45% is not contained within our confidence interval, so it's impossible for 45% of people to have received the vaccine. And then part B wants you to calculate what the smallest sample size that we can use to guarantee that the margin of error for the sample that they're going to conduct in Canada will be less than or equal to 0.02. So in order to do that, we have to set up a proportion. And so the margin of error formula is everything except the statistic. So that means that from what we used before, it's everything except the p hat and the plus or minus. So we transfer that same formula down, and then we have that the critical value times the standard deviation of the statistic is going to be less than or equal to 0.02. So we're then going to plug this into our equation over here. And so the critical value is still 99%. And so we're still going to use 0.258. And then for P, because we don't know P, because it says that 45% was only for the United States and now they're running the sample in Canada, we have to use 0.5 because that creates the largest standard deviation. And so we plug in 0.5 for P, and then N is our unknown value, so we put all of that less than or equal to 0.02. So first we just do our basic algebra, and you would divide by 0.258, and then we squared both sides to get rid of the square root, and then we multiply both sides by n, and then we divide by 0.00006. And then, well, there's supposed to be another 0 in there. And then we put this in our calculator and we get that 4161 is greater than or equal to n. So putting this in context for the answer to the problem, the smallest sample size that they can use is 4,161 people, and that means that will give them a margin error of 0.02.